So for instance, if you take the flooding in Somerset at the moment, the issue which is coming out is one of the Environment Agency not dredging the rivers. Why did the Environment Agency not dredge the rivers? Because A, it had less money, B, it has to do several things, including directives on conservation, on environmental protection, etc. And it also has to make a balance between rural areas that you can flood or urban areas that you can't flood. There's no question as, is it perhaps unusual that we've just had the lowest lows and the wettest 2 months of weather, you know, in certainly the wettest January on record in many places, certainly in parts of southern England. That's over 250 years. There's no reason why it's not going to get worse this month as well. We'll probably end up with the wettest February. You know, it's a bit like the Australian situation. The Australians are really struggling with forest fires, with global temperature, but that's not the issue. The issue is cheap energy. And therefore, you can run as many of these models as you like, with as many premises as you like, but when it turns policy and action, which will impact or not on the atmosphere, it's a political decision. It has nothing to do with the science whatsoever. Scientists can produce the evidence and come up and try and produce ranges and envelopes, but that's not the way to do it. The other thing, of course, is that these model runs are very expensive and very complex. As I say, a model run can take up to 6 months. So by the time you've planned it, decided how to run the model, how long to run the model, how to parameterize the model, how to try and change the model, then you have a huge investment in actually running those models. And most of them take several weeks of running, of very high computer time, very energy. The computer science, climate modelling is very energy inefficient. It takes a lot of energy. Again, it's this total irony that the more you want to find out, the more gas and energy you have to use. So the reality of it is that there won't be millions and millions of different model runs all available. There'll be lots, but not that many. So you know, you can't go to the Met Office and say, oh, can you just run me a model where we just tweak this a bit? And we're running to 2100. We'll just tweak energy to see if we put in 15% renewable instead of 25%. Or we do. You can't do that. You know, it is a big commitment and a decision to decide what parameters, what time scale, what spatial scale to run, and how to improve or change processes. And once you're set on the running, that's it. And of course, when you've got it out, then you've got to spend time actually working out what the output is. So, as I said, the basic idea is these ensemble predictions of several models, and that's the way that the IPCC has tended to move in the future. What I'll do is, we'll have a break there because it's getting a bit warm in here. What I want to do is just briefly, don't panic about this slide, I'm just going to highlight some bits of the slide.